Now I'm explaining you some property related to geometry. Geometrical summary. We have already covered all this. This is just a summary summarizing all the important facts which are very, very useful, particularly solving tough problems. Direct their application comes. So, first of all, this basic property you must remember. If this is any tangent, this is directrix, this is point P, this is normal, and this is focus. This point is T, this point is N. Then one simple straightforward property was SP distance. SP is equal to ST is equal to SN. That means this distance, and these three distances are equal. And we know SP is equal to PM also. Distance of the point from directrix. This is origin. This line is x equal to minus a. This P point is a 80 square comma 280. And this is 0. Equation of tangent. This line PT, Ty is equal to x plus a t square. So these three distances, SP is equal to ST is equal to SN, and this is also equal to PM. This is equal to PM also. These three distances are equal. This is the first property. Second most important property is the portion of the tangent intercepted between directrix. Suppose this is any tangent is there, intercepted between directrix and point of contact. This always subtend a right angle at the focus. So I am taking this directrix here slightly so that you can understand better. Let this be the directrix. This is 0. This line is x is equal to minus a. So this portion will subtend a right angle. This is P and this is Q. The portion of the tangent between directrix and point of contact will subtend a right angle at focus. So this will be 90-degree angle. That means angle PSQ is always 90-degree. This PQ chord, PQ will subtend a right angle at focus. So its application is, sometime we may be given a focal chord, and if I want to calculate the focus, what I will do, I will drop a perpendicular from this point Q. Q is the point of intersection of directrix and tangent. Then I can calculate S. Third important property is this is any tangent is there, this is a focal chord is there, S. As per this property, if I drop a perpendicular, it will meet here. This angle is 90-degree. This is P, this is Q, this is S, this is 90-degree. That means if I draw PQ as diameter is circle, it will always pass through focus. So circle drawn with PQ as diameter, circle drawn with PQ as diameter. If I draw a circle, then it will always pass through focus. Angle subtended in semi-lateral septum. You have already studied in 10th class. This angle is 90 degrees, so this will be diameter. So circle drawn with PQ as diameter always passes through focus S. Second property is a fourth property. Basically, if from the focus, if I drop tangent on this tangent, then that will intersect the tangent at the point where tangent at vertex intersect. So from the focus, if I drop tangent on this, that means from this focus, if I drop tangent perpendicular on this tangent, this is 90 degree, then this will meet tangent at P at the point where tangent at vertex intersect. Or in another words, I can say that locus of point of intersection of perpendicular from focus on any tangent, I will draw perpendicular from focus. Where this will meet, locus of this point is a locus of point of intersection of perpendicular from focus on any tangent is a tangent at vertex. That means, in another words, I can say if this PS, focal radius diameter, if I draw a circle, it will touch this tangent at vertex. So you can understand this way. If in this way, if I draw PS as diameter, if I draw a circle, this angle is 90 degree. So this will touch tangent at vertex at M. So circle drawn with focal radii as diameter always touches tangent at vertex. Tangent at vertex. We can draw tangent circle also here. This will touch here, small circle. This is large circle. And from this property, we are getting reflection property of the parabola. That is the most useful property of that parabola, reflection property. What are the applications of this? If you see in the field practical applications, two practical applications are there of reflection property. First, let me explain what is reflection property here. The idea is this tangent and this normal, they are internal and external angle bisector of angle SPM. This tangent is the internal angle bisector of this, and normal, this is the internal angle bisector of this MPS, and normal is external angle bisector of this angle MPS. That means tangent and normal are internal and external angle bisectors. Tangent and normal are internal and external angle bisectors of angle MPS. What is this angle MPS? This point is joined with the focus and we are dropping a perpendicular on directrix. So this tangent is the internal angle bisector, and this will become, if you extend them, this will become the external angle bisector of this angle. This angle will be same as this angle. Normal is external angle bisector. So from here we are getting reflection property. That means if any ray, any light is coming which is parallel to axis, after reflection it passes through focus. So if my light is coming in this direction, incoming light, then after reflection it will pass through focus. Or in another words, I can say, if there is a light source here and after reflection it will become parallel to axis. This is my reflection property. So sixth property you can say is a reflection property of parabola, which is maximum used. Reflection property of again, see what is the reflection property? If there is any ray which is parallel to anywhere it can be, parallel to axis of the parabola, then after reflection it will pass through focus of the parabola. This ray is coming, it is getting reflected, this is the polished surface, after reflection it will pass through focus. Reverse of this is if light source is kept here, after reflection it will become parallel to this. So if you have seen in the headlights of the motors, vehicles, car, truck, jeep, anything, a light source is kept at the focus. This is a reflecting mirror, parabolic. So after reflection, the beam gets parallel, long distance beams. A reverse process is used in case of TV antennas. There we are keeping a receptor. You have seen TV antennas like this, and then there is a receptor kept at some distance. So what happens there? Receptor is kept at focus of the parabola. Signal is coming from infinity, and after coming from infinity it is focused at, all signals are passing through focus, so it gets boosted. All signals are passing through this single point, and at that point we are having the receptor catches that signal. So these are two different applications of parabola.